Okay, it's 12 o'clock. I'm going to start recording and I'm going to charge into some problems for this week. Problems for this week are on section 17, 1:8, and 1:10. Section 1.7 starts on page 148. And the first section of problems is problems like 11 to 29 or 31 called linear inequalities. Why don't I charge into something like problem 11? It says solve 5x is less than or equal to 6. They actually want you to do three things. The three magic words are solve, graph, write in interval notation. On this one, the solve is pretty simple. You basically do whatever you would do as if it was a straight equals. So I'm going to divide both sides by 5. 5x less than or equal to 6. Divide by 5, divide by 5. X is less than or equal to 6/5. This is the solve step. The graph is not a 2D graph. When they say graph, they mean a 1D graph. So there's step 1, little step 2 is graph in 1D. One dimension on a number line. So we draw a number line, put a little tick, and label the 6/5. It would be 1 1/5. Now, this is where things start to get very technical with a less than or equal or greater than or equal. In other words, with an or equal, it's closed circles. Hope you're familiar with this. And I'm going to put a closed circle there. No or equal to, it's open circle. Oh, I've got 2 more participants now. I appreciate y'all coming in. Can y'all hear me?
Yeah.
Okay. Anybody want to identify yourself? Tell us who you are. Okay, no problem. All right, we'll just keep going with this. Let me finish this little introductory thing, and then we'll, if you've got any problems, we'll help you out. I'm in section 1.7, trying to get y'all started on the work for this week. Trying to explain all the technicalities of interval notation. It gets very technical. All right, so on these linear inequalities, you solve pretty much what you would do as if it was a straight equals. You label the number line for the graph, put a closed circle, and then you read the less than. Less than is to the left, that's where you shade. If it had been greater than, we'd have shaded to the right. And so then interval notation can be copied from the graph. I'm going to stick a negative infinity out here to try to make it more obvious. Interval notation compresses the number line down to just the beginning to the end. So I would write negative infinity and comma 6/5. And you stick an infinity on the negative infinity, I'm sorry, parentheses on the negative infinity. And on this one, a bracket on the 6/5. Okay, brackets, use brackets with or equal to, use parentheses with no or equal to. I know that's probably confusing. So let me give you the 4 cases of interval notation and try to show them with numbers. There's 4 cases of interval notation. Let's do case 1. Let's make it 3 less than x less than 5. The graph, and I highly recommend doing a graph. You'd stick on the 3, stick on the 5, and put open circles. There's no or equal to. You shade between them. For the interval notation, I'm going to abbreviate this IN. You copy down the 3, copy down the 5. And you would use parentheses. This does not mean x is 3, y is 5. That it looks identical, but that's the 2D graph case. For a couple of sections, we're going to use 1D graph case. So the interval notation can be copied directly from the graph. Use parentheses with open circles. We're going to use, this basically says the x's are between 3 and 5 are between 3 and 5, and 5 not including 3 or 5. Well, case 2, let's include the 3. That would be 3 less than or equal to x less than 5. On the graph, you'd use a closed circle because it's got an or equal to. Closed circle. At the 5, you're still open. No or equal to. You're still shading between them. And on the interval notation, it'd be 3 comma 5, but you're using a bracket here, parentheses here. Case 3 switches it up, include 5. This is include 3, not 5. This is include 5, not 3. That would be 3 less than x less than or equal to 5. 3 would have the open. 5 would have the closed. Still shading between them. The interval notation. 3 comma 5, but the bracket switches to 5. And 3 stays parentheses. And let's keep them on the same page. Let's, case 4, include both, and 5. Close circle on both. Shade between them. Bracket on 3, bracket on 5. All right, so this gets very technical. You've got to really pay attention to whether you have the or equal to's or not. Without the or equal to's, it's parentheses and using open circles. If something's got an or equal to, they're using a closed circle, and that changes it to a bracket. Before I go on and do any more homework examples, any questions about this? Anybody want to ask anything? Okay. One other technical detail. If you divide by a negative number, you switch the inequality. Let me demonstrate this. If I have you solve, say 2x equals 6, you divide by 2, x equals 3. They never have you graph this. If you did, it's very uninteresting graphing. You'd put a closed circle. And there's no real interval notation. There's no interval, no beginning, no end. It's one number. So they never have you write an interval notation for this. If we have you solve 2x less than 6, you still divide by 2. But now you've got an infinite number of solutions. Your x is less than 3. You could graph this. 3, open circle, shaded this way. On your interval notation, you've got to know to put a negative infinity this way. If it was a greater than, you'd have a positive infinity the other way. Negative infinity, comma, 3 in parentheses. The trick comes when you have negative 2x less than 6. Divide by negative 2, and your correct solution is x greater than negative 3. I hope that's not news to people. It's because if you don't switch, it's due to the sign rules. You wind up on the wrong side of negative 3. Graph, negative 3, you'd have an open circle, but you'd be shaded this way. Infinity there, interval notation, parentheses, negative 3, comma, infinity. I hope that's not news to people. I hope you've seen that before. Let's go back and try another book problem, and then we'll go on to the next section. Let's try problem 19. Well, let's make it problem 23. So this is off page. Problem 23. 4 minus 3x is less than or equal to a negative, and in parentheses, 1 plus 8x. This is 1.7, section 1.7. Pretty much do exactly the same thing you do on a normal equation. It's less than or equal, distributing the negative, negative 1 minus 8x. I would move my x's to the left. Notice there's no squares here, so you don't place square letter number. That's in the next section. Add 8x, add 8x. 4 plus 5x is less than or equal to negative 1. Minus 4, minus 4. 5x is less than or equal to -5. Notice I'm dividing by a positive, so you don't switch. Divide by a positive number. Don't switch. Inequality. X is less than or equal to -1. That is the solve. The graph, -1, closed circle, because you got the or equal to. Less than is that way. -infinity. The interval notation, -1 with a bracket. Any questions about that? Okay, let's go to the next section, which brings in squares, letters, and numbers. This is still 1.7. Let's try 33, problem 33. Solve x plus 2 less than 0. Okay, this gets technical. Let's compare 2x plus 2, x minus 3 equals 0. Everybody would know to go x equals -2, x equals 3. You're done. You switch the sign on the factor. They've already factored it for you. Switch the sign. These are the two numbers that work. -2 add 2 is 0 times this is 0. 3 minus 3 here is 0 times this is 0. Okay, there's no graph, there's no interval notation. These are the numbers. When you bring in an inequality, you have to do this, and then you're not done. The answers are intervals. You got to find the intervals that work. So you still write the x equals -2, the x equals 3. But these are not answers. You can see it. Put in -2, add 2, you get 0. Times this, 0 is not less than 0. Same thing with 3. 3 minus 3 is 0, not less than 0. 0 is less than 0. This is not true. 0 is equal to 0. Okay, so you must graph. And you put them in order on the number line, -2, 3. You read this. There's no or equal to here. Open circles on both. That indicates neither number is an answer. The answers are intervals between -2 and 3. To find them, you must test between them. There's 3 intervals on this one. We'll get to problems that'll have 4 or 5 intervals to check. That's later on. Coming attractions. This one's about as simple as you can get, just 3. You must test between them. You can pick any number you want. Pick any number you want. I usually go left to right. But you can do the middle in this one. The order doesn't matter. All right, pick any number. I'm going to go -3. I'll label this a test. So I come down here and I test -3, and I plug it in. Plug into the equation. I will get -3. I'm plugging into x plus 2, x minus 3 less than 0, which gives me -3 plus 2, -3 minus 3. I do not care the exact number. Read the signs. If you want to figure the exact numbers, help yourself. But I know this is negative. It's actually -1, but I don't care about that. I don't need the exact number. This is also negative. -3 minus 3 is -6. But a negative number times a negative number is a positive number. Positive. This side is positive. When these multiply, even though each piece is negative, they multiply to a positive. Positives less than 0? No. Positives are bigger than 0. This interval does not work. I put a big X on it just to remind myself. All right, maybe I don't have to write out all these details on the next one. I'll go 0. I always like 0. If an interval has 0, 0 is easy to test. So on the second one, I'm going to test x equals 0. I will get 0 add 2, 0 minus 3, less than 0. 0 plus 2 is positive. 0 minus 3 is negative. A positive times a negative is a negative. Negatives are less than 0. Yes, this works. Shade between -2 and 3. Third one to check, test, say 4. This is a test. This is a test. 4 add 2. 4 minus 3, less than 0. Hope it's obvious this doesn't work. Positive times positive less than 0, no. And I stick a big X. Answer. You're going between -2 and 3 in the interval to answer in interval notation. They both have open circles. Stick them in parentheses. It says all numbers between -2 and 3, but not including -2 and 3, work in this original equation. I know that's really technical. After you do a few of them, you can speed it up a little bit. But that's the kind of thing you have to do. This is called the quadratic inequality. Anybody want to ask about any of that? Let me try one more. 1.7, page 148. Why don't we try problem 37? X squared minus 18, and it's less than or equal to 0. You want to factor. Two numbers that multiply to negative 18, add to negative 3. So it could be x and x. How about minus 6 and plus 3? Negative 6 add 3, negative 3. Negative 6 times 3, negative 18. X equals 6, therefore, and x equals negative 3. These are answers. Notice the or equal to. 6 minus 6, 0 is less than or equal to 0. 0 is less than or equal to 0, yes. Negative 3 add 3, 0 is less than or equal to 0. On the number line, again, I stick them in order. 6. These are going to have closed circles because they actually work. But numbers either side of them in one of these three intervals also work. Which ones are they? I don't know. I'm dying to find out. Literally. Let's try negative 4. Test. I got negative 4 minus 6. Negative 4 add 3. Less than or equal to 0. That's a negative. That's a negative. These multiply to a positive. Less than or equal to 0? No. Positives are greater than 0. Negatives are less than 0. Let's test 0. This is testing x equal negative 4. This is testing x equals 0. 0 minus 6. 0 add 3. 0. I hope it's obvious this one actually works. Negative. Positive. Less than or equal to 0. Yes. This is negative overall. This is again times between them. Negatives are less than or equal to 0. Shade into here. Try 7. 7 minus 6. 7 add 3. Less than or equal to 0. Positive times positive. That means positive less than or equal to 0. No. Answer. You can copy the interval notation right off the number line. Negative 3 comma 6. Brackets. Basically, it means any number between negative 3 and 6, including negative 3 and 6 is an answer. You can substitute it in up here, and you will come up less than or equal to 0, making it a valid answer. Go beyond negative 3 or beyond 6, it will not work. Those are not answers. Anybody want to ask anything about that? We're at 30 minutes. Let me skip to 1-8. Maybe we can try the first one out of 1-8. Or both of them out of 1-8. There's two sections in 1.8. These are absolute value equations. Let me try a really simple one, then we'll try one out of the book. Solve. Okay. Generally, when you solve something, you want to undo. Like if you want to solve x squared equals 4. You know, my pen is getting a little faded. Doggone, I think I'm running out of ink. You would undo with the square root. Square root of x squared would equal the square root of 4x. You got to remember to do a plus and minus 2. There's no such operation with this. Nothing undoes absolute value. In fact, maybe I should even explain, just to remind you what absolute value means, what the straight bars mean. When you put a number between the bars, they mean the number between the bars. The answer is the number between the bars. Oops. So you get 2. Make that number negative, and you still get 2. That is the number between the bars. That's what they want. So it does nothing to, straight bars doesn't do nothing to positives, but they change negatives to positives because they're looking for the number between the bars, which is 2, the value. All right, let me come down to solve. I'll rewrite it down here. Solve absolute value of x equals 4. Nothing undoes absolute value. There's no magic operation. You look at the number line. And it's very similar to this in the sense that you get a positive and negative. You want to put on a 4 and the negative of it. And can you tell if I put a 4 in here, absolute value of 4 is 4. But this also works. Absolute value negative 4 is also 4. So you get 2 answers. X equals 4 and negative 4. Only. So you really don't test in between them or anything. It's a straight equals. I was just trying to draw the number line to explain why both numbers work. Absolute value 4 is 4, but you also, the negative of this number will also work, and you've got to remember that. It would put closed circles, but that's all you do, and won't even have you do this when it comes up straight numbers. You get 2 answers from absolute value. Let's try one out of the book. (1.8), page 153. Try the first one, number 5. Absolute value of 5x equals 20. So you get 2 cases based on what I just did. Case 1, set what's between the bars equal to 20. The positive version of this. Back over here on the simplest case, you set the x equal 4, case 1, and case 2, x equals negative 4. Because it's a straight x, you're done. So over here, setting 5x equals 20, divide by 5, x equals 4. You can see the check. Absolute value of 5 times 4, 20 equals 20. But you also want to set the 5x equal to negative 20. Divide by 5, and x will come up negative 4. And you can see the check. Absolute value of 5 times negative 4 equals 20. I'm checking in the original. Yeah, you get a negative inside the bars, but the bars make it positive. So both the positive version and the negative version on this one here, a lot of times they don't work out. They don't usually work out positive and negative when you start bringing in. This one happened too. You generally get completely different numbers, but you've got to check both cases. Let's try one other one. Why don't we try problem 13? In fact, maybe I should try to fit it on one page so I'm not flipping in the middle. 1.8, 53, problem 13. Solve absolute value 2x minus 3 equals 11. So first case, you would set 2x minus 3 equal to 11. That's the obvious case. Everybody gets that. But you also want to set 2x minus 3 equal to negative 11. You want to set what's between the bars equal to positive of this and negative of it. Then you do whatever you have to do to solve. Add 3. 2x would equal 14. Divide by 2. Come up with x equals 7. Same steps. Plus 3 plus 3. 2x would equal negative 8. Divide by 2. X would equal negative 4. So you're getting completely different numbers now, but they both work. Check. Absolute value 2 times 7, subtract 3. Absolute value 14 minus 3. That's an absolute value. 14 minus 3. That's the absolute value of 11. Equals 11. Check. Over here, absolute value 2 times negative 4, subtract 3, equals 11. Negative 8 minus 3. Yeah, between the bars, it comes up negative 11, but the bars turn it positive. Check. So both of these answers work. We're at almost 40 minutes. There's limits to what the human brain can absorb, so maybe we should call it there. Does anybody have anything you want to participate? Are we still kicking me? Oh, I'm back to 1. Okay, I'm back to by myself. Okay, no problem at all. And we will have a 9 o'clock Zoom meeting tonight. So we will end the meeting and see you tonight.